Next up, we have our gold sponsor for this event, NORAM. Now, NORAM's a really fantastic company. We're really proud that they are being part of the Global Mining Symposium because since the 1980s, they have built themselves up. They've built up their global reputation for innovation and excellence in providing proprietary engineering. Well, for a bunch of different sectors, but what's germane to these conversations is their expertise in mineral processing, wastewater, and possibly electrical chemical sectors as well. We're going to be joined by Randall Sarrazin. He is the manager of equipment and operations for all of North America, and Jean-Francois Magnan. He is senior project manager and business development. It's really great to have NORAM be a part of this. When we talk about innovation in the industry and driving things forward, here's a company that really is doing exactly that. So do we have Randall and Jean-Francois? Are you there with us?
Can you hear me?
Yes, I can hear you. Excellent stuff.
So for this morning, Anthony, it'll probably just be myself. I'm going to be presenting our CellChem sulfur burner technology, and I think Jean-Francois is presenting our NorScan lithium hydroxide technology tomorrow. So, we're glad to be here. We've been supplying the mining industry for quite a while, and what we wanted to do, especially with gold mining and with lithium batteries taking off worldwide, we wanted to make sure that we got our mining technology out to a great audience, and this is the perfect avenue to do that with the Northern miners. So we really appreciate that opportunity.
Excellent. Thank you, Randall. Why don't you, over to you then? I'll let you take it away and you can do your presentation.
So can you guys see that?
No, not right now. But if you hit the share screen button at the bottom of your computer screen, and then click on your presentation that you'd like to share, and then just click the share button again. And if not, I can share it for you.
Okay, let's try that. Well, Laura, maybe you should just bring it up.
Of course, no problem at all.
That's
yes,
great.
No problem. Just give me 1 second and I will definitely pull it up. There you go. You can just let me know when to change slides.
Sure. So is it up running?
It is, yes. Actually, I think it looks, let me just try one more time. There you go. You're ready to go.
Okay, that's great. So we are NORAM Engineering and Constructors. We're based out of Vancouver, British Columbia, privately owned company, founded in 1988, approximately 200 employees. Our head office, again, Vancouver downtown, that's where all the magic happens. We have a satellite office in Sweden, which handles our equipment supply overseas, and they specialize in the design and supply of SX, which is a high silicon stainless steel. We use that for absorbing towers, converters, heat exchangers, and piping and valves. We also have a company, BC Research, in downtown Vancouver as well, and they handle laboratory research and pilot plant testing. We also have a fabrication facility, world-class fabrication. It's called Axton, which is also in Vancouver, and they do a lot of the equipment supply and manufacturing for NORAM as well. They do third-party fabrication as well. So we also have within NORAM, we have several business units, and in particular, we have the sulfuric acid and nitration groups, which are our two biggest and well-known worldwide. But we also have electrochemistry, pulp and paper, biosystems, and environmental as well. So, you know, how does NORAM fit into the mining industry? So go to the next slide, please. So Typically, we use sulfur dioxide in mining. So some of the uses of sulfur dioxide, especially in the gold mining, is for cyanide destruction. You have production of sulfuric acid, and in cases like such a sulfuric acid plant, you also have leaching for copper, cobalt, and silver. So again, with sulfur dioxide, formerly known as SO2, a lot of the mining sectors are using liquid SO2 right now. So NORAM has their own technology called CellChem sulfur burners. So next slide. So on the right-hand side, what you'll see there is you'll see a typical sulfur burner for a sulfuric acid plant. Now, these type of burners can be used up to 1,200 metric tons a day of sulfur burning for like a 3,000 ton a day sulfuric acid plant. The top right is a 280 metric ton a day acid plant. So you can see the size of the sulfur burner there. And below is a sulfur burner for an 850 ton a day sulfuric acid plant. So for the mining industry, NORAM has what's called a CellChem sulfur burner. And in the top left-hand corner, you see the size of the burner, which is relatively small. Right above the yellow box, you'll see the actual furnace is very small compared to what you would see for a normal sulfur burner in an acid plant. You also have a quench tower as well, which is the vertical component. In the bottom, you have our spiral flame furnace, which goes from 4 to 100 metric tons a day. So the cyclone flame, which is in the top, is below 10 metric tons a day, and the bottom one is between 4 to 120. So next slide. So for our sulfur burners in the mining industry, especially with our CellChem units, you need a raw material, which would be your molten sulfur, and you need atmospheric air. The two of them burnt, you end up with SO2. So your other raw materials for this system loop would be cooling water and process water. On the end of the furnace, you'll see a quench tower. Interesting, for most of the sulfur burning, what you'll see is a 9 to 11% SO2 concentration in a typical sulfur burner. With our CellChem sulfur burner, you see a higher concentration of 18 to 19% SO2, and your byproduct is essentially a 1% sulfuric acid by weight, and that can be turned around and used for effluent and several other places within the mine. Next slide, Laura. So, what are the advantages of our CellChem sulfur burners? One of them is a very fast startup time. In the bigger sulfur burners, you'll have a lot of refractory, in which case on heat up, you have to take a long time to make sure the refractory is heated correctly. With our CellChem sulfur burner, you have extremely fast startup times with a very limited amount of refractory. You have a wet process on the exit, which is combusted with atmospheric air, and you get a wet SO2. The range of SO2 concentrations can be reduced, so you don't have to run at 19%. So you have some flexibility there. You have a very high turndown ratio, probably as low as 25% of design. You have a single layer of refractory, again, that helps with the heating up and cooling down cycles. And the residence time is very short, and that's the reason why we can go with such a small burner. Is we have a atomized spray for the sulfur, which ignites very quickly and very, very fine spray. So the residence time in this type of furnace is much shorter than you would have in a typical sulfur burner. One of the big advantages is a very small footprint, and it can be skid mounted. And of course, we have extensive reference list of over 180 installations of our CellChem sulfur burners. Next slide. So I mentioned we basically have two types of sulfur burners. We have a spiral flame, which is more for the bigger bigger amounts of sulfur burn, up to 120 metric tons. And then we have the cyclone flame, which is for less than 10 metric tons. And you can see it's a very small burner. On our cyclone flame, we actually have no jacket on the vessel, and we have centrifugal forces and axial gas outlets to induce the mixing. And the burner size is like a quarter of the size of a standard sulfur furnace. Next slide. So I'm going through these fast because I know I only have like 8 minutes. So I mentioned the quench tower. So our quench tower cools the gas from the furnace from 1300 degrees C down to 40 to 60 degrees C. And we have a special alloy spray cooler. The bulk of the cooling is achieved by evaporation of the circulating water, and the balance of the cooling is through an external plate cooler, and you'll see that in the bottom right-hand corner. So the tower itself is refractory line with a special alloy inlet duct to minimize the corrosion. So the spray system itself is designed to ensure complete wetting of the whole shell to avoid any hot spots. Next slide. So one of the biggest advantages of our CellChem sulfur burner is the fact that it is very small footprint, and it can be skid mounted, which minimizes your shipping and installation costs. So you can see a picture on the right-hand side, and of course the 3D model of what it would look like skid mounted. As well, you know, of course, we need molten sulfur to supply the sulfur furnace. So we also have a melting skid that can be supplied with the sulfur burner. So it depends if you want molten sulfur or if you want a prilled or bagged sulfur to come in. We have a melter skid mounted system that would feed the sulfur burner. Next slide. So, again, I mentioned liquid SO2, which is very typical in the mines right now. Our CellChem sulfur burner competes with that liquid SO2, and some of the advantages of using molten sulfur in our CellChem system compared to a liquid SO2. First off, liquid SO2 is becoming very hard to get through the market. There's a lot of taxation and I guess in the transportation of the material through whether it be rail cars or tank trucks, you have tariffs being put on by the railways to haul it because it's a TIH material. So when you're in remote locations, it's also very hard to get molten sulfur, or pardon me, liquid SO2 to site compared to molten sulfur. So molten sulfur is probably one of the most traded commodities next to sulfuric acid worldwide. So the supply of molten sulfur is always going to be there. Same with prilled sulfur. In Vancouver, we have 2 great piles of prilled sulfur in North Vancouver. So, you know, from a handling and emergency response side, the prilled sulfur is much quicker to deal with. Molten sulfur, if it's spilled on the ground, it's going to cool off and just freeze up. So prilled and molten sulfur leak, it's easy to clean it up and reuse it in the process. From an emergency response, you know, your sulfur spill on site is far less environmental impact than liquid SO2. Your on-site emergency response personnel don't have to be nearly as highly trained to deal with liquid SO2 as with a prilled or molten sulfur. So if you have an SO2 gas leak on a sulfur burner, essentially you can shut off the feed of sulfur and that'll stop. If you're dealing with a liquid SO2 leak, you're dealing with a 500 to 1 expansion rate. So if you leak, you know, 1 liter of liquid SO2 on the ground, you have 500 liters of SO2 gas. So our CellChem sulfur burner and the use of vaporized SO2 is already much less than your liquid SO2 if there is a leak. Next slide. So why use a sulfur burner? So number one, safety. gaseous SO2 versus liquid SO2, as I mentioned. You have a reduced environmental footprint and far less regulatory considerations, especially in Canada. When you're dealing with a liquid SO2, you have what's called E2, emergency regulations with Environment Canada. So there's a lot of that to consider. For economics, sulfur burners have a relatively low capex, can result in a huge OPEX savings. And if you're looking at reagent costs, so a delivered cost for solid sulfur, and again, these numbers move around quite a bit, you're looking at 250 Canadian per ton compared to SMBS, which is 550 Canadian dollars per ton, and liquid SO2, which is moving up and down, but usually on the upside is 850 Canadian per ton. So depending on the capacity of the raw materials, your savings for a Celchem sulfur burner would be in the magnitude of 2.5 to 7.5 million dollars Canadian per year, which is pretty significant when you're looking at that. So again, the Celchem sulfur burners, especially in remote locations, there's very low maintenance. Skid mounted can be placed there and really just run. All you got to do is supply it. So essentially, that's the presentation.
Excellent stuff. Thank you very much, Randall. Randall, a very compelling case there and really interesting on that. Given the advantages of the sulfur burner and the solid sulfur, where is the trend in the industry right now? Is the trend toward sulfur burners compared to the liquid?
Well, we're sure hoping so. That's why we wanted to bring our technology to the mining sector here, because it still seems that they're leaning toward a liquid SO2. It seems to be just the go-to thing. So, we wanted everybody to know that there is an alternative, and we think our Celchem sulfur burner, just based on the fact that it's got such a small footprint and can be skid mounted and brought to site, it's very viable to do this versus liquid SO2, and again, environmentally and for ease of operation, our Celchem sulfur burner, to me, is far above putting in a liquid SO2 storage tank, trying to truck liquid SO2 into remote locations, which is very hard. And the prilled sulfur and molten sulfur comes by tank truck, but prilled sulfur can be brought in by a dump truck even. You can use it in sea cans, you can bring it in tonner bags. So there's a far greater ability for supply than liquid SO2 coming to site. So I think that's one of the huge advantage for molten sulfur coming to site.
Excellent. Great stuff. Really fascinating to learn about. Thank you for bringing it to our audience's attention. And we'll wish you success in getting some market penetration on the mining side. And as you highlighted in your presentation there, this is a technology that has lots of proof cases and lots of uses.
Yeah, we're using this. Like I said, we have 180 applications in various industries, including mining. So, please, anyone reach out to us if you're planning to look at liquid SO2. We'd like to present you another option with our Celchem sulfur burner. So please reach out to NORAM, and we appreciate the opportunity to present. Thank you.
Excellent, Randall. Thank you so much.
Thanks.
I am seeing those questions. Unfortunately, we don't have time, but we're going to get those questions to Randall, and he will email you. Okay, so we are seeing those, and we'll get those sorted out. Thanks,
Thank you
Randall.
very much.
Cheers.